Hello, in this video I'm just going to be showing the code I did for the game I created, Space Conquest. So I'm just going to be showing everyone the classes, just for anyone who's interested, the classes and the things of how I did certain things. So the game is called Space Conquest, but before I thought of the name and I was creating the project, I just called it Space Game, so it's always referred to in code as Space Game. Like space game mode base. But anyway, so this is I'll start off with the spaceship character class, which is the player class, and then I'll work my way towards the game mode and all the other classes. So in the player class, first thing we got our constructor, and the first thing we do is set up our capsule component, which it's already there, but I just changed the size a little bit. I get the characters mesh and enable its collision. Set the collision to physics only. Enabling the tick function, which is the function that's called every frame. Okay, and then but these are just mainly I think they come default with the class, most of them. Then anyways, we got the static constructor helpers line, which is this line gets the static mesh for the spaceship, the spaceship's mesh. Then down here I'm creating the component that's going to hold the static mesh, which is the static mesh component. I set its collision profile name, but I don't think I actually ended up using that. I set the static mesh to the mesh that we got up here. I set up the attachment to the root component, which is our capsule collision component, and I set simulate physics equals to true. And down here I'm creating a spring arm component which is gonna hold the camera, so I called it camera boom. Again, we set up the attachment to the root component. And then there's a few other settings you do, which is absolute rotation. We set the arm's length. We set its relative rotation towards the rest of the character, towards like the collision component, and we turn off the collision test. Then finally, at the bottom here, the last component we're creating is the camera component. Then we set the attachment, this time not to the root component but to the camera boom. We get in the socket at the end of this camera boom and we're attaching it to that. And the last thing we do is we're setting the use pawn control rotation to false, so the camera doesn't rotate with the player character. He stays stationary in terms of his rotation. Then the last things we do in the constructor is just tweaking the character movement component a little bit. So I'm setting the default land movement to flying. That's to give me like the spaceship kind of feeling. Setting its gravity scale, setting its max fly speed, setting its braking speed, and setting auto activate to true. And the last thing that's been done in the constructor is setting this variable B can shoot to true. B can shoot just tells the spaceship tells the character rather whether it can shoot or not. So at the constructor, it's setting it to true. Okay, then in the begin play function, first things we do is set our player health and our player score. Then there's a bunch of variables up, down, left, and right. We set in up, down, and left to false and right to true. So that's just telling the game which direction the character is facing. So the game can rotate the character in that direction, but I'll explain this a little bit more later. Then I'm casting to the game mode, and in the game mode I am spawning a new target, but I'll get to that when I get to the game mode class. Then the tick function, which is called every frame, I'm calling the rotate spaceship function, which is a little bit towards the bottom. I'm setting the actor location to the X and the Y is set to whichever direction the player is facing, and then the Z is set to 500. And then I'm checking if the player's health is below or equal to 0, and then if it's below or equal to 0, then I set his movement to 0. Then towards here, this is I'm setting up the player input. So bind axis, which is a direction. I have two bind axis, axi. So we have the front and back, which is W, which is bound to the keys W and S, and the second one is to the left and right, which is A and D. And depending on which one is pressed, the appropriate function is going to be called. So for front and back, the front and back function will be called, and for left and right, the left and right function will be called. And what this basically does is it just adds a movement component to the player. The value here is either 1 or -1. So W, which is forward, will be 1, and S, which is back, will be -1. And then it just adds that, it multiplies that value with the value here, so it'll either be moving forward by 100 or backwards by 100, depending on the value. And then after that, if the value is equal to 1 or -1, depending on whether it's forward or facing backwards, the rotation is going to be set. So up is going to be set to true, and the rest of them is going to be set. The rest of these variables will be set to false. And same thing happens if I move backwards and if I move left and I move right. So all of these do the same thing, just in different directions. Then I have two bind action. So I have shoot, which is spacebar, and that's just going to call the shoot function, which shoots a projectile out from the front of the spaceship. And then we have the bind action for pause. Now with pause, it's going to call the toggle pause function, and there's this property at the end of it, execute when paused. So that's what that does, is it allows this binding to execute when the game is paused. So what I can do is I can press escape to pause the game, and then I can press escape again to start playing again. So that's what that property does. Then there's the shoot function. What this does is it gets the barrel location, it gets the player's rotation, and then it uses those properties to spawn a projectile of the a projectile class type, which is I'll show you in a bit. And then there's it sets B can shoot to false. So immediately after the player shoots, it sets B can shoot to false, and then it activates a timer. The timer is of 0.5 seconds, and at the end of the timer, it calls this function, which sets player can shoot to true again. So the player can't keep spamming the shoot button, he has to wait 0.5 between each shot. Then there's the rotate spaceship function, and this is where all those up, down, left, right variables come into play. So what this does is it, for example, if I'm moving right, if I press D, then the spaceship doesn't automatically just switch to facing right immediately. What he does is, depending on his current location, there'll be a little, like a rotation animation that plays, that makes him rotate from his current location to the rotation that he needs to be facing, which in this case is right. And then it stops once he reaches that direction. And then the same thing happens for the left, the up, and the down. Then at the bottom here we just have some getters and setters functions. The getters are mainly for the HUD. I think they're exclusively for the HUD. Only the HUD uses them to get the player health and then turn that value into to display that value in the slider, the health slider. So this one here gets the player's health, and then we set in the player's health. So every time he gets attacked by the UFO, his health is gonna be minused. So this function sets the player health. Then again we got the player's score. This one here sets the player's, returns the player's score again for the HUD to display the player's score there. And then set player score. So every time he shoots down one of the towers, his score is gonna go up. Then there's the toggle pause function. So what this is making use of a custom enum, which is the play state enum that I created in the game mode base. And what this does is, if the game is not paused and I press the escape button, then the game is gonna pause. It's gonna set the play state to pause, and it's gonna it's going to pause the game. And if the game is already paused and I press escape and this function is called, it's going to set the play state to plain again. And then it's going to start playing the game. So that's the spaceship character class. Then the next class is the space game mode base class. So after all of the includes, we got our constructor again, and in the constructor, it's a much smaller constructor than the player character. All this one is doing is setting our default pawn class to the spaceship character, and it's setting the previous target to -1. That is used by one of the functions later. So the begin play, we get in all the actors of what we're doing basically here is getting all the actors of, we're going to use this array to get all the actors of type this is an array that's going to store actors. So I got to confuse a little bit. And in this line gets all actors of a class AUFO AI, which is our UFO character, and it stores them in that array. So that's what's happening there. Then for every actor in the UFO array, what it does is it casts to them, and it's adding a unique well, basically what it's doing is just so the code knows how to differentiate between each of the actors in that array, and we use that a bit later. Then we setting up the HUD widgets. What this is doing, what I did here was the HUD class itself that gets displayed on the screen is not set in the code. What I do is I create a blueprint class based on the C++ code, and I set the HUD widgets there. So that makes it easier to change the HUD if I need to. And so these lines are just checking if the HUD widgets are set. So we got the HUD widget, the pause widget, the game, and the game over widget. And the last thing we do here is we set the current state to plain, so the game starts. Then spawn new target. So what this is doing, it's going to spawn a new target. This was called in the player character class. What it's doing, it's getting all actors of class A target. So the target class is the class that we need to be shooting. Then what it's doing here now is it's getting a there's another function at the bottom here that gets a random actor from this array, and using that number, it displays it activates that tower, and after I shoot it, that tower gets deactivated, and the game picks another random one to display again. So that's what this function here is doing. Let's see, and the reason I did it this way instead of like hard coding it to each one is that this way I can add multiple of those towers into the game, and the game will still run. So that's why it's done. That's why I did it this way. Just makes it easier when I'm designing the levels and things. Okay, so this function here, what this one is, it gets, once the next tower is shown, I call them targets in the code. What it does is, after the new target is shown, it gets its rotation, and it returns its rotation to the HUD. The HUD calls this function, and what that does is in the HUD there's this little compass at the corner of the screen, and that compass points you in the direction of the next tower. So that's what this function does. It just returns the rotation, or the look at rotation from the player to the target. Okay, and then there's the function that gets the random target out of that array. And in the setting the previous target, what this function is just to help the code not pick the same target twice. So it's going to always pick a new target. Then here is a function that sets the states, the getters and setters for the state. So this one returns the current state, and this one will set the new state. And this function handles the new state. So in the plain state, the game is going to be playing, the appropriate HUD is going to be displayed, the input mode is going to be set. and then it's going to do the same thing for all of the other states. So there's the pause state. The pause state is going to pause the game, display the pause state, the pause widget, and pause the game. The game over widget is going to display the game over widget. It's going to end the game, and at the bottom there's just an unknown state, which I never ended up using, but they say it's good to have it there. Not sure why, so I just added it. Then there's the projectile class. So the projectile gets spawned at the player's the barrel location when the spacebar is pressed. Now this was really easy to do actually, because of Unreal Engine's in the API they have a projectile class, and my class just inherits from that, so it already comes set with a lot of properties and a lot of functions. So it was really easy to do. What I did was I just created the again I got the mesh for the projectile. Then I create the static mesh component and set its projectile. Set the mesh to the mesh that I got up here, and I'm setting its collision profile name to projectile mesh. Then this time I'm setting the root component to the projectile mesh, and then here I'm tweaking the projectile movement component. I'm creating it actually, and then I'm tweaking it. So I'm creating the projectile movement. I'm setting the actual projectile to the projectile mesh. I'm setting its speed, the initial speed, its max speed, its rotation follows velocity, the should bounce, setting that to false, and I'm setting its gravity scale to 0 so it doesn't fall, and then its lifespan is 5 seconds. So after 5 seconds, if it doesn't hit anything, it will die, or it'll be destroyed. Then the begin play projectile mesh on component hit add dynamic, this, and I'm calling this function in the begin play. Then there's the on construction function. Now on the on construction, what I'm doing is I'm disabling the actor's collision. The reason for that is because every time I shot, it collided with the player and the bullet just stopped and it got destroyed there. I think there is a way to make the bullet permanently ignore the player's collision, but I couldn't figure it out, so I just made this small little workaround. So what it does is, when the bullet is constructed, the collision is set to false, and then again we have this little timer, and after 0.2 seconds the collision is enabled again in the bullet collision timer function, which is down here. So it sets the enable collision to true. And the tick function has not been used, so I think I should actually deactivate that. Deactivate the tick on this actor. Then there's the on hit, so when the bullet hits anything, it's going to get destroyed. But if it hits the target, then the target gets destroyed, and the player gets 5 points to his score. So that's what this class is. It's a really short class. Then the next class we'll go to is the UFO AI, which is the actual UFO character. Again, this class is really simple. What it does is firstly he's getting the mesh for the UFO, and he's getting the zap effect, which is the effect that the UFO shoots towards the player when he comes close to the player. Then again, we're activating the tick. I'm disabling the collision on the capsule component, and then I'm just creating the UFO mesh, and I'm setting the mesh again, attaching it to the root component, setting its scale also this time, and enabling its collision. Then the zap effect is just a particle effect also. I'm setting the particle effect to that, and then I'm attaching it to the root component. Then the character movement component is being tweaked here a little also. So again, it's setting it to flying, it's setting the gravity scale to 1, the max fly speed is 1000, and the braking deceleration is 1500, auto activate equals 2. And again, this class has a be can shoot variable. That be can shoot variable is controlled by the behavior tree of the character. Then there's the begin play function. So here cast into the UFO controller, which is this class here. UFO controller is just the class that controls the player. It's the AI controller class. and it casts the player character. So what this does is it's setting the player to follow to the player character, and this variable, these things are used in the again in the behavior tree, and it's just setting which player to follow, which player the AI should follow. Then down in the tick function, again we cast into the character, we get in the player's location and the UFO's location. Then B can shoot. If B can shoot equals true, so if true is being set, is set to true, then it'll activate the zap effect. It'll set the beam source to the UFO location, and it'll set its endpoint to the player location. And then I set the scale of the zap effect. I scale it up a little bit. And if B can shoot is false, so else, then the zap effect is deactivated. Okay, then we got the set can shoot. So this this is the setter for the B can shoot variable, and the can follow is, this is a return another. This is a getter for the B can follow variable, and this is a setter for it as well. So that's the UFO class. And the UFO controller class, this is the controller. This one is kind of short because most of it is being handled in the behavior tree. This one is just setting which behavior tree and which blackboard component to use for the UFO. So the behavior tree is just a kind of behavior, visual behavior thing that Unreal Engine has, and use that to program the different behaviors for your character. And the blackboard component is something that will hold the variables for the behavior tree. Now, in the game, what happens is the UFO, he'll chase the player. He'll start following the player, and that's a default Unreal Engine function where he'll follow the player. He'll find his way through a navigation mesh, and he'll go towards the player. Then I had to create some custom some behavior tree nodes. I created 2 of them, which is the attack player. This one here just basically happen when the UFO gets close to the player character, he's gonna attack the player. So he's gonna set that B can shoot to to true, and he's gonna start minusing the player's health. And then the other one I created was custom move to. Actually, I should have named that differently, but all this one here does is it sets the can follow true, so the can follow variable to either true or false. And the reason for this is what happens is when the UFO is shooting the player, he stops moving. And he shoots the player. And then if the player moves away from him, then can follow is set to true again, and he starts following the player again. So that's the custom move to. And other than that, there's the target function, the target class. The target is just a very basic actor. Again, we get its mesh, we set its mesh, we set the root component to the target mesh, and set its scale. And in the constructor, we set it hidden in game, and we disable its collision, and we say it is false. So that as soon as the game starts, as soon as it's constructed, all of these are going to happen, and these only get enabled from the game mode class. So the game mode, it gets all of the targets in the level, and then it picks a random one, and it'll call this function here. It'll show it and enable its collision, and it'll activate it. And then again, when the player shoots the target, so when the projectile hits this tower, it'll call the kill function, and that's just gonna deactivate it. It's gonna hide it. It's gonna set active to false, and it's going to call the function in the game mode class to spawn a new target. And then these are just getters and setters to set whether the tower is active. And I think that's pretty much all the classes in the game. So I mean, there's a lot of things that can be done better, but I just didn't know how. So a lot of this was just me feeling my way through the code, especially when it came to the AI, because I had no idea what I was doing. So I just had to piece information from different YouTube videos, from the documentation, and figure out what I was doing. So that took me quite a while to do. And other than that, that's pretty much all the code. It's nothing too impressive, nothing too long. Just a little project I worked on just for educational purposes. There's a gameplay video of this game on my channel, so you can check that out. I'll leave a link to it in the description. And other than that, yeah, that's pretty much it. So yeah, I'll keep posting videos of the future projects I do, and of all different gameplays and behind the scenes kind of video showing my code. So yeah, I'll see you then.